We're going to talk about energy. And we're going to talk about kinetic energy. So kinetic energy is the energy that shows whenever something is moving. Let's say you have a particle with mass. This particle has a mass, and let's say it's a baseball, and then you throw it with certain velocity. Just because of that, it's going to generate kinetic energy. So whatever moves, just because it moves, it generates kinetic energy. If you have a person that is running, you have a person running, and that person has certain mass. And just because the person is running, he's going to generate kinetic energy. So the kinetic energy is the energy related with motion. Let's do a little problem here. The formula for kinetic energy is going to be 1/2 of the mass times the velocity to the square. So there you go. That's your formula for kinetic energy. Let's say we have an example. Let's do an example here. Let's say we have an electron. So this is a little electron right here. And everybody knows that the mass of the electron is equal to 9.1 times 10 to the minus 31 kilograms. And it's going to be moving with certain velocity. So the electron is moving, let's say it's moving in one dimension. So this is going to be the velocity vector. So the velocity of your little electron is going to be 3 times 10 to the 6 meters per second. Okay, and we want to find what is the kinetic energy that is generated by this little electron just because it's moving. Okay, here we go. So the kinetic energy is going to be equal to 1/2 of the mass. And the mass of this guy is going to be 9.1 times 10 to the minus 31 kilograms. That's how you measure mass. It's going to be in kilograms. And the velocity is going to be 3 times 10 to the 6 meters over second elevated to the square. Okay. So the kinetic energy is going to be equal to 1/2 of 9.1 times 10 to the minus 31 kilograms. So we got to square everybody that's inside the parenthesis. So it's going to be 9 times 10 to the, and then 2 times 6 is going to give you a 12. And then it's going to be a 12 right there. And then you got meters. Meters has to go to the square, and seconds have to go to the square too, because you got to square the units too. So this is going to be equal to 1/2 of, if you multiply 9.1 times 9 is going to throw you 82, approximately 82. It's going to be times 10 to the minus 31 times 10 to the 12. Okay, and the units that you have are going to be kilogram meter square over second square. So your kinetic energy here is going to be equal to, so 82 divided by 2 is going to throw you 41. Times 10 to the, okay, minus 31 plus 12, because you got to add the exponential quantities. You have to add up the exponents right here. So that's going to throw you a minus 19. So it's going to be to the minus 19 right here. Okay, there you go. And it's going to be kilograms meters to the square over seconds to the square. But you want your units to be in joules, because the units of energy are joules. So how do we fix that? Well, remember that 1 joule is equal to Newton times meter. Newton times meter gives you the joule. So 1 joule is going to be equal to, Newton is by definition kilogram, meter second to the square. And this is times meters, because you got another meter right here, which would be this one right here, the one that I'm putting in a green circle. So 1 joule is going to be equal to kilogram, meters times meter is going to give you meters to the square over seconds to the square. Okay, so you can see that this is the same as this over here. Okay, so your kinetic energy is going to be equal to 41 times 10 to the minus 19 joules. And there you go. You got your answer right there. The big deal here is that nobody likes the answer in joules because the minus 19 is a very, very large quantity or very little quantity. So let's take this to electron volts. So we know that 1 electron volt is equal to 1.6 times 10 to the minus 19 joules. So 1 electron volt divided by 1.6 times 10 to the minus 19 is equal to joules. It's equal to joules right there. So let's plug this quantity right there instead of the joule right in here. So your kinetic energy is going to be equal to 41 times 10 to the minus 19. And then here, instead of the joule, it's going to be 1 electron volt divided by 1.6 times 10 to the minus 19. And if we do this, okay, we're going to do it over here. Okay, it's going to be, if you divide 41 by 1.6, I'll do it over here. The kinetic energy is going to be equal to, so from here, I'm going to go this way. Kinetic energy is going to be, that's going to throw me 25.62. 25.62. And then you got this times 10 to the minus 19. But then the 10 to the minus 19 that's in the bottom, in the denominator, is going to go up. So it's going to be times 10 to the 19. And that's going to be electron volts now. So minus 19 plus 19 is going to cancel. So it's going to be 10 to the 0. 10 to the 0 is 1. By definition, every number that you elevate it to the 0 turns into 1 positive. So your kinetic energy is going to be equal to 25.6 electron volts, which is going to be equal to 2.56 times 10 to the 1, if you wish, electron volts. So this is your answer, 25.6 electron volts. And in this case, you have solved a problem for kinetic energy. So we'll do more problems. Thank you, and I'll see you in the next one, the next problem. Bye.